Well, hello everybody and welcome to this week's project. This motherboard was handed to me with a bunch of motherboards from a local shop, and they basically just said these are all faulty. So I have no more detail other than that. When I zoom in on it, as you can see, it looks like there was some sort of spill on this. You see the marks there? And as I scroll down, there's more here, and it looks like there was something spilled on this. And up at the DC jack also there's remnants of something, food or liquid or something having been spilled. There's also bits of this same material on the board on the other side. So I don't know if that means that it's, it could be a write-off if there's serious damage done to this, but we're going to take a look at it anyway. So as usual, we start at the DC in jack, which is right here. I'm going to try and work out which is positive and negative and follow the voltage into the motherboard. Now, as you can see, we have 8 pins on this connector right here. It seems that this one is marked as pin 8, so I'm going to assume this to be 1, and I'm marking in all the pins between. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 2 groups of 2 pins. So we have 1 and 2 are connected together, and 3 and 4 are connected together. And I'm not sure what 5, 6, 7, and 8 are for. But given that these are grouped together, it's likely that these are where our positive and our negative come in. Now, even visually here, I can see which one is most likely to be the positive. Why not pause and just see if you can identify why I think that would be so. I've just gone to split screen so that we can show the schematic on the left here as well. But the reason that I would suggest pins 1 and 2 as being our positive input is because we have these 2 boxes drawn out here, as we've seen on other motherboards, where there is the option of putting an inductor. And as you can see from our schematic here, we have our positive voltage coming in and 2 parallel inductors. So I think that's the spot here where they can be put. They're obviously not on this configuration, but that is our positive. I've also confirmed by carrying out a continuity test on 3 and 4, and that is continuous with ground. So positive comes in here, ground is here, and that's where I will be injecting at a later stage. But let's just follow this along. So we've got our 2 inductors here, and after that it comes to this spot right here, which is a number of vias: 1, 2, 3, 4, 5, and 6. So they go through to the other side of the board where I would expect to find the rest of these components. So let's follow that through. On the other side of the board we can see those 6 vias: 1, 2, 3, 4, 5, and 6. So this is where it comes through here. On our schematic, we were at this point on the other side of the board, and now we can see we have our TVS diode, which corresponds to this. And also on that same point, we were also connected to pins 1, 2, and 3 of PQ8000, which is 1, 2, and 3 of this IC right here. Now this is a P-channel MOSFET, so that will be switched on if our gate is low. And if the gate is low, our voltage will come from our source pins to our drain pins. Our drain pins then, here on our schematic, are connecting to what is called VADPBL, which appears to connect onto a second MOSFET here. But let's look for VADPBL on the board and see if we can confirm that. I have located VADPBL on our schematic right here, and it says that the next component in line should be this PQ8007. There's actually no PQ markings or any markings of any of the components on the board, but we should be able to work it out anyway. So what I'm looking at here is this is the next MOSFET in line. This is not actually the AON or 21357 that I'm seeing on the board, but it is a similar 30 volt P-channel MOSFET. After that, if this is switched on when the gate is low, our input voltage is going to travel through to the source pins and then is labeled PV adapter. So that would be the drain pins coming through to the source pins here, and that would be at this point here. So at this point here, it's marked as PV adapter. And further down the laptop, I found PVADPTR. So as most of you will recognize, this is the battery management IC. This is our current sense resistor, so our voltage is coming in through our current sense resistor, and after this point it is then referred to as V in, and this is our main power rail right here. So I think what I'm going to do is I'm going to inject voltage into the 2 pins on the DC jack and then start to take some measurements and see what's working. At the start of the video I showed evidence of a spill having happened on this laptop motherboard. So the first thing I did before injecting voltage was to clean that off with a toothbrush and some alcohol. But when I had fully cleaned it off and dried it off again, I injected power, and I will show you now how I use my power supply to inject voltage onto the board. I introduce my DC power supply. I connect my black wire to ground, and I chose this spot here to inject the voltage because there's a nice big blob of solder on that diode. So I connect my red wire to there, and I set my input voltage to 19.5 volts, and let's see what happened. I've connected my power supply to my motherboard and optimistically plugged in a HDMI cable as well. So I'm going to switch on the power and see what happens here. Okay, so as you can see on the power supply, I'm injecting 19 volts and the current draw seems to be 60 milliamps, but the value is changing. It's going from 60 down to 30 and back up to 60 again. Okay, so it doesn't seem like that's correct. So what I'm going to do is I'm just going to take a few voltage measurements around the board and see where we stand. So with my power still connected to the board, I introduce my multimeter in volts DC at a 20 volt range. I place my black probe to ground, and then we're going to start taking some measurements. So the first measurement I want to take is where we are injecting power at this diode right here. So I just want to confirm that we have the correct voltage here. So when I connect my red probe to here, we measure 19.45 volts. This is our first MOSFET here, which is a P-channel MOSFET. I just want to check the voltage on the gate. Our gate is pin number 4, which is here. So when I place my probe to the gate pin of this, I measure 5.96 volts. With our gate voltage being low, I would expect our P-channel MOSFET to switch on. So I expect to find that the 19.45 volts that we're measuring on the source is coming through to our drain also. So I want to confirm that by measuring at the drain pin. So I place my probe to a drain pin and I find it measures 19.45 volts. That 19.45 volts is meant to make its way from the drain pins of our first MOSFET onto the drain pins of our second MOSFET. So I'm going to take a measurement at the drain pins here just to confirm that. So I'm placing my probe to the drain pin to the second MOSFET. I measure 19.45 volts. On the gate pin of the second P-channel MOSFET, I measure 17.4 volts. At the source pins of the second MOSFET, I measure 19.45 volts. So my 19.45 volts is making it through from the source pins of our first MOSFET onto the drain pins of the second MOSFET, and through to the source pins of the second MOSFET, at which point we were referring to this as the main power rail, if you can remember back from our schematic. So this was looking okay, however I noticed one thing. When measuring the 19.45 volts at our main power rail, I noticed that periodically the 19.45 volts was dropping down to a lower voltage and then going back up to 19.45, once every 3 seconds maybe. I initially thought that this was a problem with me not holding the probes on properly, but I managed to carefully hold the probes in place and confirm that it wasn't an issue with the probes. The voltage was actually dropping and returning to the 19.45 volts. And when I checked further back in the circuit to see if the other components were exhibiting the same behavior, I noticed that the 19.45 volts was perfectly stable at this point at the input, but that the gate pin here was also dropping and then returning to the 5.6 volts. The 19.45 volts on the drain pins of these two MOSFETs was also dropping and then returning to 19.45 volts, and the same with the gate voltage of the second MOSFET also. I located the battery management IC on this laptop, which is a BQ24780S. As we've seen a lot of configurations, these usually control the two MOSFETs on the input. However, when I checked the input for this, I found the two MOSFETs. This is the first input MOSFET, and as you can see, this is not controlled by the battery management IC. This is the second MOSFET, and as you can see, this is not controlled by the battery management IC either. However, I thought I would still take a look at this battery management IC and see what voltages we're measuring on the pins of this. So first I'm going to mark out all the pins on this IC. So these are the pin numbers and these are what they are for. Let me just zoom in a little on that so you can all see it clearly. And we're going to start at the ACDET pin number 6. Now from my data sheet I can see that ACDET is pin number 6, which obviously corresponds to the mappings I've put out here. So this is pin number 6 right here. Adapter detection input. So when ACDET is above 2.4 volts and VCC is above S or N but below ACOV, ACOK goes high. So we need to have ACDET above 2.4. So I introduce my multimeter again in volts DC in the 20 volt range. I place my black probe to ground down here and just using a screw hole. And we're going to take a measurement with my red probe. So very carefully placing my thin red probe on pin number 6. I find that it measures 2.65 volts. So this is good. However, what I did notice with this was it was periodically dropping to 1.8 volts in the same pattern as was happening for the 19 volts on the MOSFETs. So that is not holding a stable 2.65 volts on the ACDET pin. The next pin I want to check is pin number 28, which is VCC, and this is the input supply from adapter or battery. So as you can see, number 28 is right here, and there is an input capacitor at that pin, so that's actually quite an easy place to measure at instead of having to try and get my probe in at that small little pin. So with my multimeter in volts DC again, I place my probe to this capacitor right here and I measure 18.78 volts. And unfortunately, like the other voltages on this board, that 18.78 was dropping down to 17 volts periodically and then returning to 18.78. Now we know that we have power cycling to a number of the pins on this, but what I wanted to do is just take a look at the other pins on this anyway while I have it drawn out. So pin 24 is Reg N. So this is a 6 volt linear regulator output supplied from VCC. The LDO is active when ACDET is above 0.6 volts and VCC is above UVLO. So what we should be measuring when this is working properly is 6 volts on REGN, which is pin 24. So that's this right here, and pin 24 actually connects to this capacitor, so this is a good place to measure. So when I measure at this capacitor, I find that it measures 6.00 volts. However, because the input voltage is cycling, the output voltages are also cycling, and that drops down periodically to 5 and back up again. Pin 5 is our ACOK pin. So it's pulled high to external pull-up supply rail by external pull-up resistor when a valid adapter is present, and the conditions for that is that ACDET is above 2.4, VCC is above UVLO but below ACOV, and VCC above BAT. If any of the conditions is not valid, ACOK is pulled by low internal MOSFET. So I'm going to measure that just to see what it is on this. So placing my probe close to pin 5, we find that it measures 3.36, but in the same way as the other pins are cycling, that's dropping to 2 volts and then going back to 3.36 volts again. The last measurement I want to take on this battery management IC is at the ACN pin. As you can see, the ACN pin is connected through a resistor to the negative side of our current sense resistor, and at that point it's V in. So what we're measuring here is basically V in, the voltage on the main power rail. So I just want to get a feel for if that one is also cycling in the same way that the other voltages are. So on screen I have my description of the ACN and the ACP pins there. But what I want to measure is on pin 1. So measuring at pin 1 right here, I find that there is 19.45 volts. However, that one is also dropping down to 17 and returning to 19.45 volts. Just one quick note on this, guys. I'm sure there's some of you saying, why did you bother checking all of the other pins on this IC? Because, if the input voltage is going to be cycling, then obviously the other pins are going to be cycling as well. But what I wanted to do here was just bring you through how you can check the different pins on this battery management IC. Because it's so small, it might seem that it's impossible, but it actually is doable. And we can look for signs of life on it to give indications as to whether we should replace this or look elsewhere. With the laptop still plugged into my DC power supply, I decided to go round to each of the inductors on the secondary power supplies and measure and see what voltages I was measuring. Now, down at the bottom down here you can see I measured 5.1 on this inductor right here. I measured 3.3 on this inductor, 1.8 on this, and then all of the others bar this one were measuring 0 volts, but this one was measuring 1 volt. Now, what I spotted on this was that this was periodically going to 0 and back to 1 again. 0, back to 1 again. So I don't know if the fact that this is dropping to 0 is indicative of there being a fault on this one. Next, I disconnected the power from the motherboard. I changed my multimeter into resistance mode and I took resistance measurements at all of the secondary inductors. So as you can see here, I've written them all in on each of the inductors. Now, none of these looks particularly bad. The lowest measurement is 5.7 and 5.7 here, but I understand that the CPU can be very, very low nowadays. But like, none of them is 0.1 ohms or 0.0 ohms or anything like that, so I don't think there's any short. Now is a good time to reevaluate where we are. So the symptom that we seem to have is that the main 19.5 volt power rail is cycling. We've established that there's no short on the board that might be causing this. So what could it be a problem with? Well, it could be a dodgy input MOSFET, it could be a dodgy battery management IC, or the input MOSFETs and the battery management IC might be fine and the issue might be caused by something further down the line in one of the secondary circuits that's causing them to power cycle. So what are our options at this point? Well, we could just go ahead and replace the battery management IC. We could replace the input MOSFETs, but I think what I'm going to do is I'm going to chance injecting power after the battery management IC and after the two MOSFETs and see if I can get a stable 19.5 volts onto the system by literally jumping those components. This is the schematic for our battery management IC, the BQ24780S. So I want to inject after this. So you might remember that we had our input DC jack, it went to a first MOSFET, then a second MOSFET, then it comes to here onto this current sense resistor, and I deduced that this is our main power rail here. We also know that this is the battery switching MOSFET, so that this keeps control of whether the battery is being powered by the adapter or whether it's being powered by the battery. So we're going to inject at this point here. So let me show you how I set that up. We have our power supply here, of course, and we connect that to our ground. This time we're going to connect our red wire to that spot in between the two MOSFETs here. So this is the battery switching MOSFET right here, and this is the second input MOSFET. So this is our main power rail in between here. So we can connect it to either the source pins of this one or the source pins of this one. Either is connected to that main power rail. And then I set the power supply to 19.5 volts. So that's where I injected. Let me show you what happened when I did that. Okay, so this is my setup. I had difficulty soldering on a wire between those two MOSFETs, so I had to find a diode further along that same path and solder onto that. It's actually on the other side of the board, so you can't see where the wire is connecting. But when I connected in there, I pressed my power supply to switch it on, and this is what I'm seeing. So it's drawing 36 milliamps and it's pretty stable. So I'm not exactly sure what this means, but it's certainly not cycling now. So I think what I might do is I might go to the 3 volts and the 5 volt power rail and see if they're cycling. So with my 19.5 volts injected after my battery management IC, I measured these voltages again, and I measured 5.1 on this inductor, 3.39 on this inductor, and 1.8 on this inductor. However, what was different this time was the 5.1 volt was holding stable. It was not dipping down to 4.8 volts every couple of seconds. This was also stable, and this was also stable as well. That's all the time I have to spend on the video this week, guys, so we're going to have to come back to this. So as of right now, it appears that when I jump over the 2 input MOSFETs and I jump over the battery management controller and inject into the main power rail, the secondary voltages seem to stabilize. So the next step I will be looking for is to see if there's 3.3 volts on the power button, and then we'll try and power this on. So that's where I'll end the video for this week, guys. Thanks for all your comments last week. Extremely helpful. I pick up a lot from you guys posting down below. So please post if you've got any comments on this one. We'll keep trying to drive the channel forward. I'll talk to you next week. Thanks.